Hello everyone. Today we'll be solving the problem given length and sum of digits. Just give me a second here. 1 second. Yeah. We'll be solving given length and sum of digits. So this was asked in Codeforces around 277.5. I don't understand what is point 0.5 here. So this was asked in Codeforces around 277.5 division 2. Right. So here you can just go through the question. It is easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So just go through the problem. If you don't understand the problem, you can just listen to me. I'll just summarize the problem so that it will be easier for us to understand or solve the problem basically, right? So what the question states here, we are given a number length m. We are given a number of length m. We are given number length m and required digit sum s and required digit s sum s, right? So we have been given number length m and required digit sum s. So there are three criteria, right? So or there are three things that we need to find here. We have to find the smallest actually three conditions also I can call. Two things we have to find and one condition basically. So let's see. We have to find the smallest and largest m digit numbers such that the sum of their digits is exactly s. Exactly s. This one, right? So we have to find the smallest and largest m digit numbers such that the sum of their digits is exactly s. Sum of their digits is exactly s. This is first one. Second one, we have to find the numbers and also we have to ensure that numbers must not have the leading zeros. Means it shouldn't start with the zeros. Numbers should not have the leading zeros except for the number 0 itself. Except for the number 0 itself, number should not have any leading zeros where m equals 1 and s equals 0, where m equals 1 and s equals 0, where m equals 1 and s equals 0. I hope this part is completely clear, man. If no such number exists, then we have to return minus 1 minus 1. If no such this one number exists, then we have to return minus 1 minus 1, right? So this part I'm speaking of. If no number exists, if no such number exists, then we have to return minus 1 minus 1. Just keep this in mind. This is also one of the important edge cases, right? So this is fine. So again, I'm gonna read out this one loud. Just this one. Try to listen to this. Given a number length m, so we have been given number length m and the digit sum s and the digit sum s, we have to find the smallest and the largest m digit number such that sum of the digits is exactly s. We have to find smallest and largest, means we have to find minimum and maximum. Mainly we have to find this one itself, minimum and maximum digit number such that their sum is equal to such that the sum of their digits is exactly s basically, right? So this itself mainly we have to find. Numbers must not have leading zeros except for the number 0 itself. So number should not have leading zeros. This is the criteria basically. We need to find min and max, that is exactly s, right? So the sum of the digits must be exactly s basically. That's what we need to find basically, these two things, min and max. So this is just, these two are just conditions. Numbers must have leading zeros except for the number 0 itself, where m equals 1 and s equals 0. So this is one of the edge cases as well. So if no number exists, then we have to return minus 1. If no such number exists, then we have to return minus 1 minus 1, right? I hope this part is completely clear. My question is completely clear, easy to understand, right? So here let's come to the example part. Let's come to the example part, right? So here we have been given m equals 2. This is nothing but m, n. This 15 is nothing but n here. This is nothing but m and this is nothing but n here. The output that we need to get here is 69 and 96. The output that we need to get here is 69 and 96, right? So this part I'm speaking of. The output that we need to get here is 69 and 96. So for this one, 2 and 15, we have got the input, right? So 2 and 15 is the input. The output that we need to get here is 69 and 96. This is fine. This is fine. So how can I say this one? So here, this is the minimum and this is the maximum accordingly with the question that we discussed, right? 69 is the minimum and uh, 96 is the maximum. 96 is the maximum. right? So this problem we had solved in the Node.js. If you remember, we had solved 50 problems. We had solved 50 problems in the Node.js, right? So for the competitive coding itself, when I was coding in Node.js, mainly when I was coding using the programming language, this thing, Node or the JavaScript. So this problem we had solved using the Node as well. If you remember, the same exact problem we are solving it using Greedy. There we solved either using the this one. I think I had mainly solved on the topics graphs, dynamic programming, as well as this one, segment tree and the Fenwick tree. Basically, these three topics I had solved in the Node.js, right? So the same thing we will be implementing here. We'll be going with a greedy approach. Basically, we'll be going with a greedy approach, right? So we'll be solving n number of problems in Java, man. We'll be solving n number of problems in Java. No worries. So we are left with only four topics. After this problem, I'll be hopping into bit manipulation and math. So after we are done with the bit manipulation and math, so we are done with the same exact thing, last three topics, the most important topics: advanced graph, advanced dynamic programming, and the final one, segment tree, Fenwick tree, and this one, what do we call, or the sparse table as well, or the sparse table and sparse table you can consider. So these three things will be left with, these three things basically. Now I just want to say that this is m accordingly with the input, this is n, and this is nothing but min and maximum. Same goes with second input as well, m and they have given. So here I have said that if this one, what do we call, if min and max numbers doesn't exist, means if their sum of the digits is not exactly to the s, not exactly to the s, then we have to return -1 and -1. That's what they have given in the question. They have given in the question directly here. It is not possible, so we have to return -1. We have to return -1. It is not possible in the sense, this one, the sum of the digits of m will not be what do we call, will not be equal to s, will not be equal to s. Basically, that is the reason we'll be going with -1. It is simple, man. By looking itself, you can say, see here, we have been given m here. This is nothing but m, and this 15 is nothing but s. Sum of m means here this one, sum of 69, 6 and 9. Sum of 96 is nothing but sum of 9 and 6. Sum of 6 and 9 for 69. Sum of 6 and 9 is nothing but 15. 15, it is this one. 15 is same as s, right? Digit. So this is fine. One thing is minimum number is 69. And also 96 is also possible. When we reverse this one, 96 is also possible. 9 plus 6 is 15, right? This one we will be considering sum of m accordingly with the question. 9 plus 6 will lead us to the 15 again, right? So this is the maximum. Again, it is equivalent to s, and this is the maximum. Minimum is 6 plus 9, nothing but 69. Maximum is 9 plus 6, nothing but 96 here. That's what we need to return as output here. That's what we need to return as output. Same thing goes here as well. Same thing goes here as well. So here we have s equals 0. S we have been given 0. S we have been given 0, right? So there is no minimum and maximum number exists, so we have to return 0. We cannot return 0 and 0 itself, right? So here in this case we have to return -1 and -1, to return -1 and -1 accordingly with the question, right? If the smallest and largest numbers are not available, that sum of their digits is exactly s. If it is not equal to exactly s, then we have to return -1 in that case. So that's what they have given in the question. So for this one we know this will lead to the s, nothing but 15, so we have to return 69 and 96. For that we need to write the code that is different. We'll be discussing the approach further. So we have not discussed this one in detail. I'm just telling how we got this one. I mean, what are the input outputs and how we got the output. That's it. Right. So we are done with the input output part. I hope this part is completely clear. They have given us wonderful examples just for the sake of understanding. Now, now we are completely familiar with the question. Now let's discuss the approach followed by the complexities, and then let's write the code. As usual, first let's discuss the approach. So here I have considered the same first example here, 2 and 15, 2 and 15, 2 and 15. The output that we need to get here is 96. This one is nothing but n. This one is nothing but s here. Yes, the the sum of these two numbers, the sum of numbers should lead to the s basically. Right here, the sum of m, this is basically m, this is basically m. This one, see, 6 plus 9 will give us 15, which is equivalent to s, and 96 same, 9 plus 6 will give us to the 15, which is equivalent to s. This is fine. So we will be going with the greedy for this. We'll be making use of the greedy approach to solve this problem. Let's move on with the what do we call, step by step explanation part, right? So here m we have 2, s we have 15, the same input I have considered the first example. To find the maximum number, we have to find the maximum and the minimum number, right? So we have to find the maximum and minimum number, right? So in our case, maximum is 96 and minimum is 69. That's what we need to find, right? So here we will start placing the largest possible digit 9. Largest possible digit 9 from the left to right to maximize. So first we will be considering 9. Out of 0 to 9, 9 is the largest digit. So we will start placing the largest possible digit 9 from left to right, just for the sake of maximizing. Just for the sake of maximizing. So here first digit is min of 9 comma 15. 15 we have s here, so we will be considering this one s basically, right? So this one will be 9 comma 15, 9 comma 15, right? So here sum of the left here is, sum left is nothing but 6. Sum left is nothing but 6. Right. So second digit we will go with minimum of 9 comma 6, because sum left we have got 6 here. Sum left we have got 6 here. So we, instead of 15, we will be considering minimum of 9 comma 6. So min of 9 comma 6 here as 6. Here as 6. Sum left is 0. Sum left is 0 here in this case, right? We have got sum left 6 and sum left 0, and the minimum we have got here as 9 comma 6, 9 comma 6 here. So maximum we will go with 96. Maximum will go with these two digits, right? So maximum is 96 here. Maximum is 96. These two digits we will consider basically 9 and 6. Minimum we have got 9 and 6, right? So we will consider 96. Same we will be similar thing we'll be doing for the minimum number as well. We will build, instead of building from right to left, we will build from left to right, as we have to go with the minimum number, as we have to go with the minimum number, right? So we build from left to right, choosing smallest valid digit at place, at each place. So maximum number from 0 to 9 is 9, so we considered this one to find the maximum number, right? So minimum number is 0, we will use this one first to find the minimum, right? So we build from left to right, choosing smallest valid digit at each place. First digit can't be 0. Here in this case, usually we'll be making use of 0, right? So 0 to 9, so smallest is 0, but here first digit can't be 0. First digit can't be 0, so we will check from 1 to 9. We will start from 9. First digit can't be 0 because in the question they have strictly mentioned it shouldn't contain 0 leading zeros. It shouldn't contain leading zeros, they have mentioned in the question. In while reading the question also, I have stressed this one. I had stress this one basically. It shouldn't contain 0 except the number itself is 0, right? We shouldn't have the leading zeros except it is the number 0 itself we are considering, when we are considering the number 0 itself, right? So here first digit can't be 0, so we have to check from 1 to 9 where remaining sum fits, where the remaining sum fits here, right? So here for each place we will ensure remaining sum minus d is less than or equal to 9 into remaining positions, basically remaining sum minus d into remaining positions, less than or equal to 9 because numbers we are going with 1 to 9, sorry, not 0 to 9 here, 1 to 9, right? So this has to be less than or equal to 9. Less than or equal to 9, we have the digits from 0 to 9 where we are not starting from 0 because they have asked in the question that it shouldn't contain trailing zeros, so we will be going with 1 to 9. You can count from 1 to 9, right? So the number has to be less than or equal to 9, less than or equal to 9. So here remaining sum minus d has to be less than or equal to 9 into remaining positions, into multiplied by remaining positions basically. First digit we will try d equals 6. D equals 6. right? So d equals 6, where we will be going with the 15 minus 6. We will be going with the 15 minus 6. So maximum we have already got 96. Here in this case, first digit we will try d equals 6, nothing but 15 minus 6 is 9. 15 minus 6 is 9. So this fits in one digit. So we will keep 6. D equals 6 we are considering with. Basically, we will keep the 6 because we have got the 9 which is less than or equal to 9. Remaining sum minus d, this is less than or equal to 9, right? It is equivalent to the 9. So we will keep the value 6. We will keep the value 6. Next digit is 9. Next digit is 9 basically. 9 fits. 9 fits. Again, it is equivalent to 9 basically. Remaining sum minus d is less than or equal to 9. So here 9 fits. So we will keep the number 9 as well. So we will keep the number 9 as well. So in turn we got the number in turn we got the number 69 here. In turn we got the number 69. So minimum here is nothing but 69. Minimum here is nothing but 69. Maximum we got 96 and the minimum we got here as 69. Maximum we got here as 96 and the minimum we got here as 69. So the output that we got here is equivalent to the output that they have given for the example 1 within the question. Again, minimum we got here is 69 and maximum we got here as 96. Minimum we got here is 69 and maximum we got here as 96. The whatever the solution, whatever the output that we got is equivalent to the output that they have given for the example 1 within the question. So our approach works absolutely correct. Our approach works absolutely correct in this case. As we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The time complexity would be big O of m into n. Big O of m into n. Because for each digit, in the worst case, we have to go with the 9 iterations, right? For each digit, in the worst case, we will be going with the 9 iteration to find the right digit in the minimum loop. To find the right digit in the minimum loop, right? So we are going with what remaining sum minus d less than or equal to 9, nothing but from 1 to 9. From 1 to 9, we are not considering 0 because it shouldn't start with the leading zeros. Unless the number itself is 0, we shouldn't consider 0, right? So that is the reason we'll be going with 1 to 9 here. In this case, for each digit, worst case, in the worst case, we have to carry on with the 9 iterations to find the right digit in minimum loop. So the overall time complexity would lead to big of m into n. Overall time complexity would lead to big of m into n. So what will be the space complexity here? The overall space complexity would be big of m. Overall space complexity would be big O of m here. So when I say big O of m, we have to store two strings of size m. We have to store two strings of size m for minimum and maximum, right? We will be storing two strings of size m for minimum and maximum because 69, see, we have to store this one and this one, right? 6 plus 9 will lead to 15, right? So same thing goes, any example you take, 96, this will be 9 plus 6, this will be 15 accordingly with our example. So we have to store two numbers here. We have to store two strings, sorry, we have to store two strings of size m for minimum and maximum. For minimum and maximum here, this one is minimum and this one is maximum that we got for the example one basically, right? So after doing this, we have to go with this one as well as this one. For that reason, we'll be going with the we'll be storing two strings of size m for minimum and maximum basically. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n, big of m into 9 and big of m respectively. So now as we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. Let's start writing the code. Let's start writing the code now. So I'll just come here. Yeah. What shall I do? Now we'll be making use of the utility packages. So I'll just go with the, let's import the, this one. I'll just go with java.util. Let's import the utility package here. So this is fine. And let me go with the class name main. You can just give the question name itself or anything. That is, what is happening here? Let me delete this one. Yeah. that is relevant to this question basically, right? You can just give any question, this one name that is relevant to this question. So here let me give main. So this is fine. So let me delete this one entirely. So we don't have to go with the input output exception, I think. Let's see, let's write the code. So we have to read the input. I'll be making use of the scanner here. So this one will be new scanner, this thing system dot in. So this is fine, system dot in, this is fine. So here we have to read the number of digits required, and we have to read the required sum of digits as well. Nothing but in the input we have been given m and s, right? If you remember, we have been given m and s. So I'll just go with int m equals scanner dot scanner dot next int. This is fine. So let me copy the same thing here. Let me copy the same thing here and let me paste it over here. So this one will be n. This one will be n. So this is fine. Uh, the next thing is we have to go with the edge case. Nothing but only valid 0 is m equals 1 and s equals 0. Only valid 0 is m equals 1 and s equals 0. This they have given in the question itself, man. This they have given in the question itself. We shouldn't go with the this one trailing zeros or the leading zeros, or and also the only valid 0 is when m equals 1 and s equals 0. This they have given in the question itself. This is one of the edge cases. Let's write in the form of code. So if I can just write it in this way, if s equals 0 and m equals 1, then we have to go with mm, this one 0 0, right, within the strings. So I'll just go with 0 0. So this is fine. Next line, we don't have to return anything, so I'll just go with return. This is fine. Let me come out of this one entirely. Let me come out of this one entirely. So if it's impossible to form such number, if it is impossible to form such number, then we have to return -1 -1. That also they have given in the question. So whatever we have discussed in the approach, we will be articulating the exact same thing in the form of code here. So let's try to write that in the form of code. Nothing but here, if s equals 0 or s greater than 9 into m, then we have to print -1 -1, right? So I'll just go with println here, system out println. So we have to give -1 here. This is fine. So I'll just go with the return. I'll just go with the return here. So this is fine. Let me come out of this one entirely. Let me come out of this one entirely. So first, what shall I do? I'll just give here. Let me assign this one to s. Let me assign this one to s, and also let me go with string builder, string builder max. Let me assign this one to new string builder, new string builder. uh yeah, this is fine. So the next step is we have to build the maximum number. We have to find the maximum and minimum number itself, right? First, let's build the maximum number by making use of the greedy approach. So I had said this one while we were discussing the approach. So I had said that we will be going with a greedy approach, right? So we'll be going with a greedy approach to find the maximum, basically to find the maximum. So we will build the maximum number by greedily taking max digit from left to right. From left to right we are considering, as we have to go with max, as we have to go with the, or as we have to find the maximum number. So we have to build the maximum number greedily by taking maximum digits from left to right. So let's go with the, or let's move on with the iteration part here. This will be int I equals 0, I less than m, I plus plus. So this is fine. So within the for loop, I'll just consider digit and assign this one to math.min of 9 comma sum, 9 comma sum. So this is fine. The next step is we have to append this one to the result. Nothing but max dot append of digit. So this is fine. So next thing is we have to reduce the remaining sum. Nothing but sum equals sum minus digit, sum equals sum minus digit. So this is fine. I'll just come out of this one. So this one, let me assign sum to s. Also, let me go with the string builder here. Let me assign minimum to new string builder. So this is fine. This is fine. So next we have to build the minimum number as well. Means we have to find the minimum number and the maximum number. We are done with the maximum number part. Means we are going with a greedy for this one. We went with a greedy for to find the maximum number. Now we will build the minimum number by choosing the smallest valid digit from left to right. From left to right. So let's go with the two for loops here, two nested loops here. This will be for int I equals 0, I less than m, same thing, I plus plus. This is fine. So within this for loop, I'll just go again because we have to build the minimum number. We have to build the minimum number here by choosing the smallest value digit from left to right, right? So I'll just go in this way. We can write in this way: int d equals, if I is equal to 0, if the value of I is equal to 0, then we have to display 1, else we have to go with 0. I'm just making use of the ternary operator here. This is fine. And d has to be always less than or equal to 9. This one we have discussed in the approach already. It has to be from 1 to 9. It has to be from 1 to 9. It shouldn't be 0 because it shouldn't we shouldn't go with the leading zeros unless the number 0 itself. For the number 0 we have already written this one here. If the only condition is s can be 0 when m equals 1, when the value of m is 1, then we have to return 0 0 0. Else if s equals 0, we have to go with the minus 1, right? So here in this case I equals 0. If I equals 0, then we have to display 1, not the 0. Else we have to display 0. That is the reason we are making use of the ternary operator here. This is fine, I hope, right? Then let me increment d here. This is fine. Let me increment d here. So this is nothing but the first digit cannot be 0. The first digit cannot be 0, right? If I equals 0, then we will display 1. We'll consider that one as 1. First digit can't be 0, right? Now within this for loop, we have to check if it is possible to fill the remaining digits with the remaining sum, right? We have to check if it is possible to fill remaining digits with the remaining sum. For that, let's write the simple if condition here. This will be sum minus d less than or equal to 9 into this one, m minus i minus 1, m minus I minus 1. This is fine. Within the if condition, we have to append the valid digit. We have to subtract from sum. We have to append the valid digit and we have to subtract from sum. To append the valid digit, I'll just go with min dot append of d. Min dot append of d. This is fine. And we have to subtract from sum as well. Sum equals sum minus d. So this is fine. Uh, we have to break out of it, right? So everything, if everything goes well, then we have to break break out from here. So I'll just make use of the keyword break here. So this is fine. I'll just come out of this one entirely. So we are left with only one thing, means we have to print the minimum and maximum numbers, right? So we have to print the minimum and maximum numbers. If you observe here, we have the minimum number 69 at first, and we have space, and we have maximum number here. So we are making use of the scanner, so I'll just go with the system out println here. This one will convert this one by making use of this one to string. We'll be making use of to string, right? So this is fine. Let's append space. We need space here, right? So also we have to go with the maximum again, max dot to string here, right? So this is it for the code. This is it for the code. This is it for the code. We are done with the code. So before checking the code with different inputs, I want to copy paste the signature starter template, right? So just give me a second here. So I'll just come here. You can just ignore this one. So yeah, let's focus on the logical part here. So I hope the code works absolutely correct, man. Let's see. Let me copy this one. We have to get 69 and 96. See, we are getting the error. Error cannot find the symbol. Variable s. We have declared variable s, right? We haven't. So yeah, we have directly made use of m and n. So just give me a second here. We haven't declared s at all here, so let's do one thing. So yeah, instead of s, I have given n here in the line number 25. This we have in the input, we have m and s, right? So we know this one. So in a hurry, I have typed n, I think. So this is fine. Let me hit the run button again. Yeah, now we are getting the output 69 and 96, right? So this works absolutely correct. So this was the problem basically, right? So let's see. Now let me copy this one. We have to get -1, -1. I hope we get the correct output. Let's see. See here, we are getting the correct output -1 and -1, right? So whatever the code that we have written works absolutely correct for the all the examples that they have given in the question. Let's see whether this works for all the test cases or not. So let me paste the same thing over here. So I have already selected problem C here. This is C itself, right? Yeah. So let me submit. Let me hit the submit button here. I hope this works for all the test cases, man. Let's see. Let's wait for some time. So I can clearly see here running on test 19, 27. Let's wait for some time. So here you can clearly see the code got accepted, right? The code got accepted. So whatever the code that we have written works absolutely correct for all the test cases. Whatever the code that we have written works absolutely correct for all the test cases. Very simple question, man. This was very simple actually, right? This was very simple question basically, to be frank, right? It was easily solvable, right? So I hope the solution part is completely clear. We made use of the greedy approach to find the max, and the minimum we just chose from left to right, right? So that's it. So mainly we have made use of the greedy approach to solve the problem, this particular problem. So we are done with this one, what we've called intervals and greedy. So we are done with the topics intervals and greedy. Next, let's solve some problems on bit manipulation and math mainly, right? So let's solve some problems on bit manipulation and math basically, right? So for now, I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.